Okay, hello everyone. I welcomes to all in our lecture series on mathematical physics, that is your core paper 8 belongs to 4th semester B.sc physics on our syllabus CBCS model. In our last class, we have been discussed this question number 11. Find LS of Fz equal to 7z minus 2 by zq minus z square minus 2z in three different regions. In detail, we have been discussed in three different regions for three different functions. Here we found by after partial fraction, we found this function, this function, this function. Separately, we evaluated the Lorentz series in different regions. In detail, we have been discussed, and I told that in this class we are going to discuss this question. But before that, I'm going to say you one thing that, or one information, that this particular question or this type of range question in different books they have been done in different way. Okay, what is that way or method or procedure, you can say, they have been considered, that we are going to discuss in this particular class. Then we are going to go further. In our next class, we are going to discuss question number 12. Okay. So here I am going to start to discuss what is the different method. So here I am going to show you. See, for the first bit, suppose I am going to consider first bit. Here we considered this range, and we found the, by considering mod function what is the range, or by considering the circular equation also what is the range we found, and we considered that the center is your minus 1, and we found the Lorentz series of 1 by z, 1 by z minus 2, 1 by z plus 1, and we substituted. Some other book they have been transformed. Here you can see, I'm going to show you. Some other books they have been, what they done, they taken that t equal to z plus 1. If I'm going to do so, then what will be the range will be t mod. Here z plus 1 mod will be t less than 1. Got it? Now if I'm going to find out its range, suppose I'm going to consider upper limit, then what would be limit will be minus 1 to 1. And if I'm going to consider lower limit means what, t is less than 0 and t is greater than 0. That means here it represents t equal to 0, and here it is represents minus 1 to 1 range. Or if I'm going to consider the circular equation form, that means we can write like this: t mod can be written t minus 0. That means here 0 is the center, 0 is the center, and 1 is the radius. 1 is the upper radius or larger radius, we can say larger radius, and 0 will be the smaller radius. So now what will be the range for this case? If I'm going to consider 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 1, minus 2. So here, as we transformed the limit z plus 1 equal to t, so what will be the center? Center is at here. Center is at here. That is your t0, not z0, t0. t0 at 0. And what is the range? Minus 1 to plus 1. Minus 1 to plus 1 range. By mod function we got the same, and another point is the here, this point. And if we are going to consider circular equation also like this region we are going to consider, right? So here I'm going to zoom somewhat. So here t0 will be 0 and range will be minus 1 to 1. Now we are going to solve uh, I'm going to solve for you one each and every function. Here you can see, if I'm going to consider 1 by z, see, now I'm going to find out the Lorentz series of 1 by z. So how we are going to do this? See, we considered t equal to z plus 1. If it is so, if t equal to z plus 1, then this z, instead of z, what we can write? T minus 1. So instead of z, we can write t minus 1. Okay, now, so 1 by z will be 1 by t minus 1 when we consider t equal to z plus 1. Now we are going to find out the Taylor series of this one about t0, which will be equal to 0. Now for this case, what is the singular point? The singular point is 1, and corresponding t0 equal to how much? 0. So t0 is 0 and singular point is your 1 here. So here you are standing and you are moving in this region. That means what is the case? Case is your out to in case. Out to in. So on this we have to apply out to in approach or tricks, you can say. What we have to now, we are going to write t minus 1 will be written as 1 by out to in case means what we are going to write. Wait. Yes. So out to in means 1 by z dash minus z0 minus z minus z0. So here instead of z we are considering t. So what we have to write? We have to write t dash minus t0 minus t0. Okay. So here your singular point is your 1 means it will be considered will be as t dash. Wherever the singular point, that will be considered as your t dash or z dash. Previously whatever we have been discussed, right? Now you just put the values. T dash is your value is 1, 1 minus 0, then minus t minus 0. If I'm going to match this and this, so it is 1 by 1 minus t, here 1 by t minus 1. So only for that we have to multiply minus for equalizing both the side. So what we are going, 1 minus 1 by 1 minus t. The first term will be taken outside, that means minus 1 by, if I will take outside this one, obviously we are going to get the same 1 minus 1 by 1 minus t. Here 1 by 1 minus t series will be nothing but, already minus is there, n equal to 0 to infinity t to the power n. Got it? So we found t to the power n. So by substituting t value, that is your z plus 1, we can found that summation over n equal to 0 to infinity, t value I have been substituted z plus 1. So z plus 1 to the power n. Okay, by this method also we can get the same answer. Here you can see we found for this case 1 by z, what we found, minus n to the power n, z plus 1 to the power n. So here also z plus 1 to the power n. So I suggest that you go by this way, because here you have to consider t, again you have to put the t, so you have to use some, or you are going to write some extra steps. But in this way you have to straightforward means, I told that in your exam you should not write this mod function things. You have to write this one circular equation format. You draw on the figure means your 70% work has been completed. Then you have to find out one by one Lorentz series and you have to put in the main function, right? Likewise, you can also validate the result of this one. For suppose I am going to consider for 1 by z minus 2, 1 by z minus 2, for this range also you can validate by considering t equal to z plus 1. You can validate. Now I am going to validate for you this one. Okay, this one, that second bit, that is your 1 to 1 less than that of the z plus 1 mod, less than that of the 3. I'm going to validate for 1. Here we found, by this procedure we found 1 by z Lorentz series is this much. Okay, 1 by z plus 1 to the power n plus 1, or this one 1 by z plus 1 into n equal to 0 to infinity 1 by z plus 1 to the power n. This much we found. Now we are going to validate that same result we are going to get by considering t equal to z plus 1 or not. Okay, here you can see range. Here it has been given that 1 z plus 1 mod less than 3. Okay, now I am going to consider z plus 1 equal to t. So what will the range? T mod. So here what we done, here for this case your z0 equal to minus 1. If I transformed to t, here range is your in the form of z, but if I transformed to t, here you can see its center will be at 0. This will be the center, that means here z0 will be 0. That means I moved this here in the figure, this point will be moved to the center only, nothing else. Okay, now I'm going to validate. Okay, just watch. So for this case, after substituting t equal to z plus 1, we found this one. I'm not going to go by the mod function by finding the range. I'm going to go for by the circular equation. So this is your lower smaller radius. This is your larger radius of the circle, and this is the center. Now we are going to draw this figure. That means 1 2 3 4 5 -1 -2 -3 -4 -5. Okay, here I am drawing roughly, but whenever you are writing your note, no, you have to draw perfectly, otherwise circle it will be not beautiful. Circle will be not that much exactly that you are going what I am expecting from you. Okay. Okay, so here the T0 is your 0. This is the center at 0. Then larger radius is 3. 3 means here 1 2 3 4 5 -1 -2 -3 -4 -5. So larger radius means up to 3. This one 3 here with 3 tak ho jayega. From -3 to 3 it will be extended. Okay, -3 to 3. Then smaller radius is 1. Smaller radius means 1. This one. So what is the range now? So what is the range or region? This is the region. In this region, we have to find out, right? Now, one function I am going to do for you, and other also you can validate. 1 by z is there. 1 by z, what we have to write now? 1 by, here, z plus 1 t means z will be t minus 1, right? So, t minus 1. T minus 1. Now, for t minus 1, 1 by t minus 1, we have to find out the Lorentz series in this region. So, here you can see for this 1 by t minus 1, what is the its singular point or the so-called z dash is your 1, and we know that for this function z0 equal to 0. We got the two informations, and at this here 1 is here. So here you are standing, okay, and you are moving in this region. That means in this region at any point, that means the work is your in to out work. You are in inner somewhere and you are moving out. Now we are going to put this information. We are going to use this information into out. So for that t minus 1 will be written as 1 by, see, for into out means 1 by z minus z0 minus z dash minus z0. So here t we are going to consider t minus t0 minus t dash minus t0. Okay, so 1 by t is arbitrary, t0 is your 0 minus t dash. T dash means here z dash, sorry, this will be z dash, sorry, t dash, I written z dash. So t dash, that means singular point. T dash is your 1, then t0 is your 0, right? So here you can match 1 by, here t minus 1 is there, here also 1 by t minus 1. So no need to multiply minus, we got t minus 1. So I told that what will be the first term that we are going to take the common. So t after taking common, so it will be 1 by t. So 1 by t will be always less than 1. Here you can see in this region, if I am going to consider any any arbitrary point means here t, because we transformed from z to t, no. Okay, for this arbitrary point you can take any point in this region. Suppose for the simplicity you consider on this real axis, consider 2. So 1 by 2 less than 1. Consider 1.1, because we have to consider above 1 below 3. So 1.1, 1 by 1.1 also less than 1. So as this one, as 1 by t less than 1, so what will the final series? That's n equal 0 to n equal 0 to infinity t to the power n. But we consider that t equal to z plus 1. So what it will be? By substituting t value as z plus 1, we found this one. Okay, what we found in this way. Okay, so I suggest again that you just consider this method. Some other books they have been done like this, but in this way you have to do some extra steps. Okay, so I suggest you have to do by this method. Now I'm going to validate this one, 1 by z minus 2 for you. That will be last, and other you can validate by yourself. Suppose we have z minus 2, no. Z minus 2 means, here I'm going to show you, for this 1 by z minus 2, by this method we done and we found this one, the Lorentz series is this one. By considering z plus 1 equal to t, also we can found the same. Here you can see z plus 1 equal to t, z equal to t minus 1. So this will be transformed to as 1 by t minus 1 minus 2. So it will be 1 by t minus 3. Okay, 1 by t minus 3, right? Now for this function, what will be its t dash? T dash is 3, and t0 is your 0. So where is the 3? 3 is here. So you are standing here and moving somewhere inside this region at any point z. That means you are moving out to in, or your work is out to in. So for this, what is the hints? Out to in. Out to in concept we have to use, or tricks we have to use, and we have to transform 1 by t minus 3 by considering Lorentz series theorem. So here out to in means what we have to do? 1 by z dash minus z0 minus z minus z0. Here instead of z we have to consider t, right? So here 1 by t dash minus t0 minus t minus t0. Just substitute. T dash is your value is your 3. 3 minus t0 is your 0 minus t minus 0. So if I am going to compare this with this one, it is not matched. Here 3 minus t we can get, but we have the original function 1 by t minus 3. So I have to multiply minus with this one. Now it is exactly matched, but it is transformed in this format by using this is the Lorentz series theorem. So we found 1 minus 1 by 3 minus t. What is the first term? 3 taken outside. So we found 1 by 3 taken outside. So it will be 1 minus t by 3. Okay, t by 3. So minus 1 by 3 into 1 by 1 minus t, what we consider t as z plus 1. So instead of t, you just put z plus 1 by 3. Okay, z plus 1 by 3. So first we have to write, the series. Okay, here first we have to write the series, then we have to put the t value. So here you can take t by 3 in this region always less than 1, t by 3. So you just consider 1.1 value here, 1 point divided by 3 less than 1. Here 2.9, 2.9 by 3 also less than 1. So t by 3 always less than 1. So what will be its answer? Its answer will be minus 1 by 3 into summation over n equal to 0 to infinity t by 3 to the power n. Okay, Lorentz series, because this is 1 minus t by 3 is there. So this will be t by 3 to the power n. So minus 1 by 3 instead of t, what we have to write? Z plus 1. Summation over n equal to 0 to infinity z plus 1 by 3 to the power n. Exactly matched. Yes or no? Here you can see. So here you can see that we got the same result. By this method we got the minus 1 by 3 summation over n equal to 0 to infinity z plus 1 by 3 to the power n, and by that method in our previous class also same result we got. So here I suggest to all of you that you just consider this method what we have been discussed in our last class, because by this way you have to consider two extra steps, that you have to consider first z, and then you have to reconvert the z plus 1 you are going to consider t, then t will be reconvert. So 1 or 2 steps you have to consider by this way. So I suggest that in which way we have been done in our last class, you consider that procedure or method and practices, write it in your note perfectly for your exam. Okay, so again I'm going to suggest that if you want you can write in this way also. In this way, if you want, you can also write in this way, in by this method. Okay, now here I'm going to stop this lecture. In our next lecture we are going to discuss this question, 12 question number 12. LS of this function z square plus 1 by z into z square plus 3z minus 10 about z equal to 0. Thank you so much for watching this video. Thank you.